Hi, in this video, I will be showing you problem number 35 of chapter 16, section 6. Find an equation of the tangent plane to the given parametric surface at the specified point. R of uv is u cosine vi plus u sine vj plus vk at the point u equal to 1, v equal to pi by 3. So here we are asked to find out the equation of the tangent plane to the specified surface at a specific point. The parametric values of u and v are given. So using that, we have to actually find out the point. That means we have to plug in u equal to 1 and v equal to pi by 3 into r of uv to find out the exact point through which the tangent plane is drawn. Tangent plane to the surface in parametric form. We now find the tangent plane, we'll find out the formula, to a parametric surface S, traced out by a vector function r of uv, which is x of uvi plus y of uvj plus z of uvk at a point p0 with a position vector r of u0, v0. The point P0 corresponds to the parameters U0, V0. R sub U, which is the partial derivative of R with respect to U, is given by dou x by dou ui plus dou y by dou uj plus dou z by dou uk. Here, dou x by dou u means partial derivative of x with respect to u. Dou y by dou u means partial derivative of y with respect to u. Dou z by dou u means partial derivative of z with respect to u. R sub v same way is dou x by dou vi plus dou y by dou vj plus dou z by dou vk. If Ru cross Rv is not 0, then the surface S is called a smooth surface, meaning it has no corners. For a smooth surface, the tangent plane is the plane that contains the tangent vectors R sub u and R sub v. And the vectors Ru cross Rv is a normal vector to the tangent plane. The vector Ru cross Rv is a normal vector to the tangent plane. So if we know the normal vector and if we know the point through which the tangent plane is drawn, it's easy to find out the equation of the plane. Now here we are given R of uv equal to u cosine vi plus u sine vj plus vk. So from this we can actually determine the partial derivatives. This is given as a parametric surface. Now tangent plane is required at the point corresponding to the parameters u equal to 1 and v equal to pi by 3. So using this condition, we will find out the point R0, which is R at 1, 3. So if you substitute u equal to 1 and v equal to pi by 3 into R of uv, we get 1 cosine pi by 3 I plus 1 sine pi by 3 j plus pi by 3 k. So this will give us the vector half I plus root 3 over 2 j plus pi by 3 k. That is the position vector of the initial point, or the point through which the tangent plane passes. So we need only the point, so we don't have to write the vector representation. R0 vector, or the position vector corresponding to P0, is half root 3 by 2 pi by 3 with the angle bracket, meaning it is vector representation or the position vector of the point P0. At the point, if you write, it is the point form, xyz form, which is half root 3 by 2 comma pi by 3, is where the tangent is drawn, and the tangent for which the tangent plane at that point has to be evaluated. Now R of uv is u cosine vi plus u sine vj plus vk. From here we can determine the partial derivative with respect to u, which will be cosine vi plus sine vj plus 0k. So Ru at 1 pi by 3 can be obtained by plugging in u equal to 1 and v equal to pi by 3 into r sub u, which is cosine pi by 3i plus sine pi by 3j, which is half I plus root 3 over 2j plus 0k. So we got r sub u. Similarly, we have to determine r sub v. R sub v is obtained by differentiating with respect to v. So it is negative u sine vi plus u cosine vj plus 1k. So R sub v at this point, 1 comma pi by 3, or at the parameters corresponding to 1 comma pi by 3 would be just negative sine pi by 3i. So in here you have to plug in u equal to 1 and v equal to pi by 3 in this relation. So we get negative sine pi by 3i plus 1 cosine pi by 3j plus 1k, which is negative root 3 by 2i plus half j plus 1k. So we found out Ru, R sub u and R sub v. We can get the cross product of these two in order to get the normal vector. So the normal vector to the plane is a cross product of these two, which is R sub u at 1 comma pi by 3 cross R sub v at 1 comma pi by 3. So if we take the cross product of 2 and 3, just determinant I, j, k in the first row. Second row are the components of R sub u, which are half root 3 by 2 and 0. Third row are the components of R sub v, which are negative root 3 by 2, half and 1. We expand that, you get root 3 by 2i minus half j plus k. So this becomes a normal vector to the plane. Now we know from 1 the point through which the tangent plane passes, and from this relation, the last step, we got the normal vector. Now the question is only to write down the equation of the tangent plane. You have to find the equation of the tangent plane. Passing through the point, half root 3 by 2 pi by 3, and whose normal vector is n equal to negative root 3 by 2 I minus half j plus k. So here we are going to use the equation of the plane which is a times x minus x0 plus b times y minus y0 plus c times z minus z0 equal to 0, where a, b, c are the components of the normal vector and x0, y0, z0 is a point through which the tangent plane is drawn. So the equation of the tangent plane at half root 3 by 2 pi by 3 is given by root 3 over 2 times x minus 1 half plus minus 1 half y minus root 3 over 2 plus 1 z minus pi by 3 equal to 0. Hope this video helps.